Hello viewers, Alan here. Welcome back to my workshop. So, continuing with the Lynx engine, this time I'm going to get stuck into the cylinder head. Work starts on the lathe, so let's get over there and get straight into it. So I've got my stock set up and I've turned the outside diameter to size of 57mm, and I'm getting ready to do the features in the start on the features in the bottom face. So in the lathe here I have to put two recesses into this face. The smaller one's 25 diameter, the larger one 30 diameter. The smaller one has to go in for 5mm and the larger one for 1.5, and the larger one needs to basically match the protruding cylinder liner cap or rim around the top of that. But anyway, we'll start off by putting a hole, and I've got a flat bottomed slot drill here. I'll go in, I think, 4.5mm, leaving myself 0.5mm to clean up with a boring bar, and then I can start opening that centre hole out for the two different diameters that I want. Right, that should be 4.5 deep, so we get the slot drill out the way. According to this we've got 4.56, that's pretty good. So I'll do my first pass with the boring bar to open the diameter out at 17mm, and we'll see what that looks like, and 4.5 deep. So first up, let's see what diameter we finished up getting. It's a bit tricky this because it's not a very deep hole. We actually got pretty close to 17. So it's not bad for a calibration pass. So we'll leave it at that for the time being. Now, what about depth? That's the other thing. It's a bit of a burr there. Let's see whether this little fella can get it. That's alright. Okay, now the only depth micrometer I've got is imperial, so we'll have to do some conversions. Alright, final pass. We're looking for 25 diameter, 5mm deep. Time to get the homework marked. Alright, let's see what we get for diameter. 25 would be nice. $25,005, oh, I can live with that. Yep, happy with that. So what about depth? Clean that burr off again. Now, see what we get here. Hopefully it will translate to 5mm. Oh, it's upside down. Alright. Okay, I've got to work out how to read this thing again. Just under 0.197. Maybe 0.1968. Well, let's see what that translates to. Yeah, well, I'm happy with that. We can call that 5mm. So breathe a sigh of relief. So I've finished on diameter and on depth. So now I can move to the second diameter. So this next diameter is to fit over this cylinder sleeve or liner, outer diameter there. It's nominally 30, but when I actually turned it, I got 30.0403. So that's what's going to govern my size here. I'm going to rough it out to 30 diameter and 1.5 deep, which are the nominal sizes, and then we'll take it from there. Only way I'll be able to measure this is with the calipers, isn't it? So that should be 29. well, I'm pretty happy with that. So we'll go out to 30. Alright, well, that should be 30 and 0.16. Sorry, and 1.6. Well, we've got the 30. See if we got the 1.6. No, I'm going to read this fool of a thing again. Yeah, I forgot to have record running there, but anyway, I've taken it out to a 30.05 and 1.61 deep. Right, let's see if we can give you a close look at what's happening here. So, that is a spectacular fit. Let's back out a bit. Anything I don't know for sure is whether the face, which face on this is making contact with the face here, whether it's the large one or the bottom of this little chamfered thing. So I've put felt tip pen marks on the major face and also on the minor face, and we'll just make sure what's touching where. It's not actually that clear where it's touching. Oh, we've gone through there. I think it must be touching more on the, maybe it's touching both. Okay, well, it's definitely touched more on the outer ones than the inner ones. Well, I think I might be leaving it there. Right, so I'm getting set up now to cut grooves to create cooling fins in the cylinder head. And I would like to have used my proper grooving tool, which is properly flat across the front. Unfortunately, it will only go into 2mm deep, and these grooves have to be 3mm deep. So we'll be using this fella. The fins are 2mm thick and spaced at 3mm apart, but the first one has a different offset from the face here, and I have to, the first groove, if you like, is only 1.5 wide. So given this is 2, I've got to go in with a 0.5 offset. Right, that's got things started. So now we have to go over to 3.5, and that should give me a 2mm fin. I'll just do a quick check on that, as I can make mistakes very easily. I've shown that over and over. Yeah, 2mm. So I didn't go quite full depth, so I'll do my second cut here, 1mm offset over, and then come back to smooth the bottom out. And that's my first fin. Rinse and repeat. Okay, well that's 3 fins successfully done, so on to lucky last. Let's see if I can do this without messing it up. Right, well, successfully made my 4 fins. Do a bit of deburring and have to chop it off. So I've cleaned up the fins and grooves, getting ready to part off. And looking ahead, the top surface of this piston will be cut back a little bit to expose a rectangular boss for the cam box to be mounted on. And so the top surface around the edge of the cylinder head will be back a little bit from where I parted off. So I'm going to put a groove in here which will allow me to put a chamfer on what will become the around the top surface of the cylinder head. I guess that will become clearer as we get further in. And I'm going to part it off. I'll part it quite deeply, but then take it over and cut it off with a saw, I think. Because, well, this wouldn't reach all the way in anyway. Yeah, well, let's get into it. That is starting to bind up a little bit, so I won't try and go any deeper with this. Alright, so let's get the chamfer on here. Yeah, that should do. Alright, whip it out of the lathe and hack it off. The cutting fluid in this saw is suffering badly from neglect. Yeah, well, it should be changed. But it's one of those things, isn't it? Well, hopefully there's enough material there for me to get the boss out the top. The finished overall dimension is 31.5, so I think we're laughing. Okay, so I'm facing what is going to be the top of the cylinder head here, and I've got it held, as you can see, using a bit of Coke can, which was a tip from one of the viewers, which I'm very grateful for. Seems to be working just fine. Anyway, we're currently on 32.3. I want to get to 31.5. Right, well, I should say that for better or for worse, that's going to be it. Well, let's do a check and see what we finished up with. Right, well, that was unbelievably jammy, but I landed right on the 31.5, so I can't complain about that. Okay, so that's finished the lathe work on the cylinder head, and Greg's drawings are really helpful. He's broken the machining of the cylinder head into several discrete chunks, and this represents the completion of the first chunk. But from here, they need to have holes drilled in the bottom for the valve guides, and also holes drilled in the top for various things. And the cylinder, I'm going to do the cylinder head bolts first, and you can drill them obviously from either side. What I'm going to do, and Greg certainly made some suggestions about some ways to do that, but I've decided what I'm going to do is, because this is a really good fit on there, and it's indexed by the top of the cylinder liner or sleeve, I'm going to mount this on there and drill through, and doing it that way I can drill large holes first, clearance holes for the bolts, down to about here somewhere, and then from there the 4mm holes for the bolts themselves. And doing it that way, the depth I have to go to with a very small drill is greatly reduced, so hopefully that will improve the accuracy. When this is sitting on there, I've made up a couple of clamp plates and some threaded rod bolts here, hold down bolts, so that'll hold that quite firmly in place. I'm going to use this one when I'm drilling the 8mm holes, because I can put quite a worthwhile amount of force on that, and then perhaps switch over to this one when I do the 4mm holes, because the chuck has to be able to get closer to the job. So to make sure that I'm not fooling myself with the accuracy of things here, I ran the dial gauge around the top of the cylinder, and oh, it's out of focus, is it? Come on. I think you can see, for the bit of it you can see, it's tracking around. The variation all the way around is within 0.02, or about 1,000th of an inch. So I dare say the drill will wander off more than that, so I'm happy with that. Yeah, okay, well I'll move on to the next step, which is getting set up with this clamp and so on. Okay, so I think I'm set up to go now. Now, the drilling these cylinder head bolt holes is not really a trivial thing. There are to be 8 bolts, but they're on spaced on a 10-hole pattern. So 2 of the holes are blind and won't be drilled. They're just there to locate the drill. So I'll start with the one that you can see. But each of these hole drillings is going to be a bit of a business. I have to do a 14.6 deep at 8mm. That's a clearance hole for the head of the bolt, and then the 4mm bolt, or through a 4mm hole to the bottom of the cylinder head. That's another 16.9, and then lucky last I have to drill into the cylinder to create the thread for the M4 with a 3.3. So it's a multi-stage thing. And I'm going to rely on each of the drills leaving a cone point in the bottom of the hole to start the subsequent drill in the centre of its hole. When all that lot's finished, I'll come back and run this slot drill with a flat bottom to put a flat bottom on the bottom of this hole for the head of the clearance, the hole which gives clearance to the head of the cylinder head bolt. It's all a bit of a mouthful, but anyway, it's as I say, a multi-step process. I think maybe the problem is this is so close to this, it's not clearing the chips properly. Right, well that's gone down to 14.5. So we'll switch over now to the 4mm drill. It goes down 31.5. Not sure what I'm going to do here now. I'm going to lose this down the hole, but I don't think it's going to. Yeah, I haven't got enough shank to get hold of there. Have a bit of a head scratch here. Alright, so what I'm going to do is, this is a 1/8 drill. The correct tap size for M4 is 3.3 or perhaps 3.4. There's a bit of debate about that. But anyway, this one's 3.18. But I think what I'll be able to do is push it down the hole, and it can act as a dowel pin. See, this cylinder head is a very close fit on the top of the sleeve, so it can't translate, it could only rotate. And with this acting as a dowel pin, I think we'll make sure that doesn't happen. Then I can change this over to the skinnier one. See how we go with that. Well, that's the plan. Let's see how it works. Right, that did in fact come out in the right place, or what looks like the right place. So have a bit of a clean up and then see whether this works while I change this over to the other clamp. So I realised that this 1/8 drill's made a pilot hole in the cylinder, which I can easily pick up to drill out to 3.3 for the tapping. So I'll just do another one of these holes on the back side here, and then I won't need to worry about all this clamping arrangement. So I'll bring you back when I've achieved that. So I've opened this hole out with the correct size tapping drill, which is 3.3. I run a taper tap through it, or an intermediate tap through it, and I'm now putting the bottoming tap through. I'm going to watch carefully when it comes out the bottom, so it doesn't start digging into the next fin over. If I had that in the right place, it would help, that little telltale. Right. I think coming out of the bottom now. You just touch that telltale. Right. Okay, get the tap out and clean up. Doesn't take much to put a chamfer on a small hole in aluminium. Okay, well I think it's time to see if the head will go back on and the holes will line up. Alright, so I'm going to put a long bolt through so I can find the hole. Get another long bolt for the other side. Right, so snug those 2 bolts up and they'll hold it in position while I drill the other holes. Okay, well that's got all 8 of my head bolts drilled, tapped and countersunk. Oh, I don't need that anymore. That was an alignment tag. I don't need him now. So I think the next thing is turning this upside down, finding a way to hold it so I can drill the valve guide holes. So just for the fun of it, I've put the cylinder head back on, turned 180 degrees to see how well the bolt holes line up. And in fact, it worked pretty well. That's all 8 bolts in. It doesn't fall onto the central locating spigot, but that doesn't surprise me because that's a very close fit. But I reckon if I pushed it, it probably would go on, but that's amazing. So yeah, the DRO's done a splendid job of locating the holes for me. Seeing that the hole pattern was sufficiently uniform that this would fit either way around gave me the idea that maybe I could put it on upside down. And it looks like I can. So I've made up a couple of it's just a little bit loose just on the bolts because they're sticking out through these big holes. They don't have the same location as if they're coming out the other way. So I made up a little threaded dowel pin things and made them a good fit in there. I think you see that. They're pretty good fit in the cylinder head. So put a pair of, I decided 2 was enough. We'll put this on upside down and this face will index against the top of the cylinder liner. I'll have to stand on my head here to see where we're going. There we go. And it doesn't really move at all. So 4 bolts in there. And I think I've got this thing by the short and curlies. It's aligned to the cylinder, of course, and it's not going anywhere. And why are you playing hard to get? One of these is a bit bent actually. Yeah, the threads on the end of 1 or 2 of these aren't particularly true. I don't know quite what's going on, but I noticed that before, so use a different bolt and I haven't got the problem. It's not my layout, it's the bolts. Right, get its washer on. See, all these bolts are perfectly aligned. The DRO did a fantastic job. And that's not going anywhere. So the next feature is 2 big holes for the valve guides. So as before, I'm going to drill the large part of the hole first using this short machine type drill because they're very stiff and won't wander off course very far, and it'll leave a divot in the bottom of the hole which I'll use to send in my 5mm, well 3/16 drill, because I'll run a 5mm reamer through that. So hopefully that will give me the best chance of having a hole that comes out in the right place on the other side. Bird's nest there. Alright, and I think we'll move over and do the other one while I've got this set up. The kookaburras in the background. So drilling the holes in this sequence, the smaller drill only has to keep itself straight through 15mm or so of stock instead of 25. So I've got a better chance of it coming out in the right place. I think actually I might run the reamer through while I'm here. Right, so now I'm going to open this hole out to its final size of a 10mm diameter for a depth of 11mm. The depth, I'm going under what's shown on the drawing, because the drawing includes a generous allowance to make sure that the guide bottoms in the register that I'll be putting in. I think that's probably really useful if you have to drill this hole to size using a 118-degree point drill, because then the bit of extra space at the bottom might come in handy. But I'm using a flat bottom end mill, so I don't need to go more than nominally past the relevant length of valve guide, which is 11. So I'll be going down to 11.2. Okay, so I'm getting set now to create the register in the top of the hole, and I thought I might have been able to get away with using 7/16, but not so. The holes are on the hole centre spacing is 14mm, and with an 11mm end mill, it adds up to 25, which is the cylinder bore. So basically, you're going to have an 11mm end mill. Anyway, the depth required here is 1.6 to make sure that when the guide, which has a 1.5 thick lip, is pressed in, it goes at least flush, slightly beyond flush with the what will be the cylinder head or cylinder chamber face. Now, normally I do this sort of thing using the quill DRO, but the quill DRO I've got is well, it's good enough for most things, but it's not that reliable. It's not that accurate, I don't think, and also it's very slow registering movement. So I'm going to, in this case, use the Z-axis DRO and obviously wind very slowly. Well, that's one done. Off we go for another 1.6. So hopefully you'll be able to see that recess a little bit more clearly. So I flip the cylinder head back over to the correct orientation, and I want to check whether the holes I drilled for the valve guides have come out in the right place. They're reamed to 5mm, and that's a 5mm dowel pin, or pin gauge in the quill, and it's not. I don't know that it's perfect, but it's pretty bloody good. I'm not hearing any clicking or seeing any bending, so that's that hole, and the other one, 14mm away. That was its nominal position drilled from the other side. Well, whether they're perfect or not, I don't know, but that pin gauge is quite happy going straight in there. So regardless of whether they're perfect, I think they're good enough. And so I can, I think, continue to set the rest of the features off the OD of this thing. I mean, yeah, I've got to use the dial gauge to centre it, obviously, at the moment, so I might as well work off the outside of that as try to work off those holes. So the job at hand now is to open these holes out to what's a fairly non-standard size of 12.5mm diameter, but the holes need to have a flat bottom, because a spring will sit in the hole and seat on the bottom of the hole. So my original thinking was to do the boring using the boring head, because this particular head can also do facing. But I've never used it in that way, so that's going to be a bit of an experiment. But the first problem I've encountered anyway is that the smallest boring bar that it comes with has a 10mm shank and a sleeve or a collet I guess, to fit in with the boring head. But I don't have a collet that has an 8mm shank, and the only boring bar which I've got which looks suitable for the job has an 8mm shank. So I started making another sleeve or collet, and I will finish making it. But I've started to have second thoughts a little bit about whether or not this is the best way to go. The only alternative, I mean, short of sourcing a 12.5mm end mill, if they exist, I suppose they do, is of course to carry this over to the lathe and mount it in the forejaw with an offset and do the machining that way. And at the moment I'm really not sure which way I'm going to go, but I've made most of this sleeve. I've got the OD, ID and a cut on this side, so I will finish making that, because if I don't use it this time I'll use it for something else. So I'll just finish making that and then go back into a huddle with myself. So finishing this collet off, as I said before, I've got the OD and ID correct. The wall thickness is 5mm because it's 18 OD and 8 ID, and the cut I've done on this side is 4 thick, so it'll leave a 1mm thick piece to be a hinge, and the other side I have to cut right through, so go in at 5mm. And this arbor has gallantly offered its services because it's going to get destroyed in the process. Getting ready for the final cut now. The previous pass took it to 4.8, so this one I'll take it to 5.05 or something, just to make sure we actually cut through. Well, hopefully that's done the business. And I think that worked out alright. Just got to decide if I want to use it now. Still, if not for this job, it would come in handy for another one. So I decided I'd give the boring head a good try, and our first step was to do a practice hole and to set the outer diameter. And to help with that process, I machined up a plug gauge to 12.5mm, and as I've got this set at the moment, as the boring head is set at the moment, I think you can see that that's pretty much on size. So that's that part of the deal. So the next part of the deal is working out how to make the boring head face across. I think I've got it set up so that it is in fact now tracking in the right direction, and so my intention at this stage is to bore the hole on size and then back it into the middle to face the bottom of the hole off. Well, that's the plan. A couple more practice runs to do yet before I let this loose on my workpiece. So I've done a few practices and I'm ready to do a dress rehearsal now. This bit of scrap's only 3mm thick, so I'll go in 2. Well, actually I'll go in 1.8 with this and then 2 with the boring head, and see how close we can get to the required result. Right, there's 1.8 and 12, so we'll switch over to the boring head. Since I only have to take 0.5mm off the diameter, which would give me 1/4mm depth of cut, I'll try to do it in a single pass because that'll make my life easier. We'll go down to 2mm now and then stop and then engage the facing feed. Now that's stopped on depth, so I think before we do the facing operation I will just check that I've got the diameter right. Yeah, happy with that. Right, and I've got the torque reaction arm set up. That's off, yes, that's, well, let's see what happens. And yes, that did kick out. Well, I have to give it a little bit more grip. See if that's enough. And we had success that time. Right, so I thought I'd just give you a closer look at how the bottom of the hole turned out from that facing operation. Pretty impressive, I think. So it's certainly good enough for what I'm trying to do, for the spring to sit on. And as you saw earlier, the hole is to size. I'll move on now to do it for real on the cylinder head. So this is the first one, done to depth and correct diameter. Just do the other one now. Well, my new collet seemed to work out just fine. It's quite a snug fit in the hole. Anyway, so it's a useful addition. The boring bar's a good fit in that in here too. Be careful I don't hurt myself on the oh, there we go. Well, that was definitely worth the effort. Right, so I've exposed the valve train boss by milling away around it, and the valve train boss is supposed to finish up 14mm wide. Well, something went a bit wrong with my milling and I finished up 13.9, but I think I can accommodate that when I make the cam box cover. The length that way is alright, and I was supposed to hit 2.5 depth. Well, I got 2.48, so I guess that's close enough. Now I'm getting ready to drill the hole pattern for the cam box, and it's important to note that up to this time all of the features that have been machined into the cylinder head are symmetrical about the crankshaft axis and an orthogonal axis to the crankshaft. But this hole pattern for the cam box changes that. It's offset to the rear slightly. So if in your machining you finished up with a cylinder head bolt pattern that's not interchangeable front to rear, you need to make sure that you put this hole pattern in correctly, offset to what will be the rear of your in your arrangement. Okay, so I'll drill the hole pattern and then that'll finish the features on the top here. Oh, one other thing, you can possibly just see the chamfer on the edge here. This is what I put in when I was cutting the fins. In hindsight I should have made it a bit more pronounced, but nonetheless there it is. Okay, so that's finished machining all of the features that have to be put into the actual top face of the upper surface of the cylinder head. So, and you can see here the holes I drilled as the bolt pattern to hold the cam box on. I worked out why my dimensions went off for the valve train boss. When I was measuring it, I forgot to allow for or to recognise that there were burrs on the corners from the milling operation. So I got a false reading when I was reading from the end. Live and learn. Anyway, next step for me, perhaps you can see down here, is to make an angled face here, 60 degrees or 30 degrees, depending where you measure it. And the purpose of that flat face is to present the opportunity to drill a hole or bore a hole for the spark plug. So that's obviously needed a new setup, and that's what I'm going to do next. So I'm set up here to machine a flat which will take the drilling for the spark plug. In theory this is straightforward, but I'm a bit nervous about it because we're trying to locate off angles and things rather than off flat or easy to locate surfaces. So I've also got a chamfer here that might affect things, so we'll just have to see how we go. Right, well, let's see how that looks. 1st millimetre. Okay, so now I'll go at 5 deep. So starting to get close to the given measurement is 44.6 from that back side to the edge of the cut. We're currently on 46.6, so that cut line's got to go a couple of millimetres further that way. Alright, I think I've taken my last cut, and the only real dimension I had to work from is the dimension from the edge of this new cut face to the back here. Should be 44.6. It's pretty hard to even see where that edge is. I reckon that's about it there. We've got 44.58, so I'm happy with that. To drill the hole for the spark plug, I have to locate the centre away from this edge here, which was left from this facing operation. And it's pretty hard to pick up probably, but I've tried to put that point directly over that ridge as best my old eyes can tell. But as something of a cross check, if I put this feeler gauge blade in there and bring the pointer down, if I'm too far this way, nothing much will happen. If I'm too far that way, the blade will tip down. So let's see, just about to touch it now, I think. Yeah, so it's in fact just, I think you'll be able to see that's just tipping the blade, but that's all the movement it's creating. And I think, well, I might be fooling myself, but I believe that movement is a result of the diameter of the ball point on the end of the thing here. Anyway, be that as it may, that's as good as I'm going to get it. So I'll use that as my datum for locating the centre of the hole. So the spark plug hole is described as 5.4 all the way through, which is about 25 millimetres, and about a 17 millimetre counter bore, 12 in diameter, to give a spanner access to the spark plug. Now a 5.4 drill has got some substance to it, but as I've done previously, I'll use a really stiff drill to start with and reduce the amount of distance that this thing is going to have to hold the line. So this guy's only got to go through maybe 8 or so millimetres now, so it should be able to keep itself straight for that distance. Right, well, we've got a hole through into the cylinder. Let's hope it's in the right place. Now I'll change the tools over and do the 12 millimetre counter bore. Right, we're on 17.7 now. I don't really understand why it didn't want to feed in that, but anyway, we got there, 17.7. So now I have to put a thread in the bottom, the quarter 30, or is it quarter 32? Quarter 32 thread in the bottom of the hole. Right, well, I'm pleased to see that the spark plug went in alright, and the spark plug hole came out in the right place. Happy to see that. So that's a lot of the machining on the cylinder head done now. Well, very satisfying to see the spark plug go in, minuscule as it is. You will have gathered, I imagine, that it's taken quite a lot of work just to get this much of the cylinder head done. I sort of thought at the start I might have get it all finished in this episode, but it's just a lot of machining, a lot of different setups, and I had to make a couple of tools along the way, and it just all takes time. Anyway, I hope you found that video interesting. For the next one, I'll be trying to finish the cylinder head off. So that means making the valve guides, the valves, and then running the ports in. With the valve guides installed, I'm hoping to run the ports straight into the guides. Then there's some fins to put on the top, and a couple of external faces to bolt carburetors and exhaust pipes onto. Yeah, so still quite a bit to do. Anyway, hope you're finding it enjoyable and hanging in there with me, and I look forward to seeing you on the next one. Cheers.